Hello, thank you for coming to my talk. So as you're probably aware, I'll be talking about what we've done at Juice to build a HIPAA-compliant analytics platform on AWS. We'll start off a little bit about me and Juice. I'm a husband and father. My wife and I just had our 3rd anniversary this week, and my son just turned 2 last month. I'm the Director of Platform Engineering for Juice, which is a kind of a fancy sysadmin title. I'm obsessed with automation, and I'm a permaculturist, which those of you who aren't familiar with the term, I use it as kind of a philosophy on looking at nature for inspiration when it comes to designing systems and making use of the natural cycles of waste and using the waste as input for fuel and reducing the amount of work you have to do. I'm interested in using systems to improve our lives and our mental health. This is the feeling I seek. But this is the feeling I often find. I'm sure you all can probably relate a little bit. A little bit about the company I work for, Juice Analytics. It was founded in 2005 by 2 brothers, the Gimignani's. I was started out as basically a custom dev shop that did consulting with companies to help create data visualization apps and to help to present data in interesting ways to non-technical people. We're the creators of Juicebox and other atrocities. It's not currently a public product, but find me afterwards and maybe I could set something up for you. We basically help companies build data products. And over the past 10 years of doing that, we have gone from more of a custom kind of setup to building a platform to help us build these apps faster. And right now it's all internal. But we hope to eventually open source it, or not necessarily open source it, but open source some parts of it and to allow access to the platform by developers and third parties. A little bit about our role as it pertains to the pipeline of HIPAA data and PHI data. I'll talk a little bit about what analytics platform actually means. It's not that complicated. And what it means to be a third party when it comes to HIPAA data and our responsibilities. And I'll talk a little bit about our tooling, but not too much because that's a whole other series of talks. So an analytics platform, our role in this basically is we acquire data from clients and we load it into Redshift. And right now that's our primary backend, but we have developed other backends. And then we serve an application to end users. So we are not the producers of this HIPAA data, so we don't have as many of the strict guidelines that comes with producing the data. So we're actually a business associate. This basically involves legal agreements with different companies and chains of insurance. So we sign this agreement with any clients that want to serve PHI-based applications on our platform. And we signed an agreement with AWS as well. A little bit about our tooling. We've gone into this and we're using Terraform to create all our AWS resources. We're using CredStash for managing passwords and secrets. And this is basically a small Python library that uses KMS and DynamoDB to help store credentials. We use Salt for configuration management and orchestration. And we also use Docker files in some of our newer, smaller services. Django and Flask for applications. And we run all our Docker stuff on ECS right now for non-PHI based stuff, nothing that can actually process PHI. And we use AWS Lambda for a handful of things. All right, so show of hands, who has general experience operating HIPAA-compliant systems? And how many of you have experience actually operating these systems on AWS? Yeah. All right, well, I'll talk a little bit about the basics of what it means to be HIPAA compliant. It sounds scarier than it is, and when you start really looking into it, it's basically the stuff that you would want to do anyway. You want to encrypt everything at rest and during transport. Log all access to any protected health information. And you have to have some kind of change control processes. For us, this is ticketing systems and code review. And so these access logs that you accumulate, you have to store them for 6 years. They have to be discoverable up to then. Don't share accounts. Basic. Not that you'd want to anyway, but don't. Have password policies. And have password policies. Do backups. And have a disaster recovery plan in place. All right. So our kind of must-haves that we had when we started building this, and we really started building this, I guess it was about 5 months ago, I want to say. I think it was actually more like 3. So the first thing we wanted was infrastructure as data. So we don't create anything manually in Terraform except for a few pesky things that have to be done with every account setup. We require multi-factor authentication for any access to AWS. And a little bit about that, we've actually created a IAM policy that when I set up a new account for someone in AWS, a developer or a sysadmin or whatever, they have a policy that allows them to log into the console and they can't do anything else other than set up a multi-factor auth device. And then they can poke around in the console, they just can't see anything except their own stuff. So once they do that, they're good to access other things based on their other policies that they might have. We use separate AWS accounts per environment. So we have a separate account for dev, staging, prod, and we also have an account for control access. Any type of orchestration we might do across accounts, any sources of truth like centralized auth, they live in this one central account. And this basically means we have one account where everyone's users are created. And the other accounts, they don't have any users. And it requires actually assuming a role to access the other accounts. Some of the benefits of the multiple accounts. One benefit is that for every account has its own free tier. So a little bit of free money. It also allows you to do consolidated billing. So we can see our billing broken down based on every account and every environment that we might have. It gives us more isolation, improved security, and also allows us better gating for infrastructure changes. Something will blow up completely isolated in dev, and that's what we want. So the centralized logins obviously reduces quite a bit of risk. All right, so I'll talk a little bit about about HIPAA as it pertains to actual AWS services. So the basics is you actually have to go to Amazon's website, and I think it's actually aws.amazon.com/compliance. You go there and you fill out a request form. You can put in your phone number and email, but I don't think they use the email because they tried to call me. So I ended up delegating that to someone else. So the second thing is you have to actually use specific services. So they have a white paper that defines which specific services that you can actually use and how you use them. So this is the full list of the services that you can use in AWS to actually process any PHI data. You'll notice RDS is specific for certain engines. So we can't store any PHI in Postgres RDS, for example. And also DynamoDB, the last on the list, you actually have to utilize KMS if you're going to put anything containing PHI data. So you have to encrypt it before you put it in DynamoDB. The rest of the services support encryption in some way or other. So a little overview. KMS is Amazon's key management service. How many of you actually used KMS at all? Right. That's quite nice. It allows you to create master keys that are stored with AWS. We never directly retrieve them or have any kind of access to it. And if you want to use your own keys and stuff, it also supports using the hardware modules. So you can actually import your own keys and if you need to. We don't do that. So it gives you a key, and then it basically gives you an API for encrypt and decrypt, and a couple other API actions that allow you to work with the data. So services that actually support KMS built in, they call KMS from service accounts. Redshift, for example, comes from its own IAM account. The second thing is you have to enable logging for all the services that support it. Logging tends to go to S3 for anything that supports it. So Redshift, you turn on logging and it goes to S3. S3 logging goes to another S3 bucket. Different services structure their logs differently. S3, for example, looks a bit like syslog. So anytime someone accesses an S3 bucket, you get a line output and it gets delivered to S3. CloudTrail logging, this is what tracks API calls. Specifically, it tracks create, modify, and delete API calls. So anytime any of those things get touched, you get a log entry that tells you what account it came from, what user, what role they might have been using, and what resources they actually modified. CloudTrail logs are actually structured JSON logs. And other thing is to use IAM roles everywhere you can. IAM roles, for those of you who don't know, are awesome. They allow you not to have a access key and secret key. So every time you use these roles, you actually have to assume a role. And when you do this, you acquire temporary scoped credentials from Amazon Security Token Service. And these have various timeouts. Like by default, when you assume a role, it's 1 hour. And also, every time you assume a role, CloudTrail logs it. So the basic, we're able to give our admins and our devs really limited credentials, and when they want to elevate those credentials, they assume a role. And this is supported by the AWS command line, the console. So I actually log into the main account, and I'll switch over to the dev account, back and forth. It's a lot funner than logging in and out of accounts and opening incognito browsers. So a little bit about the pipeline that we've actually built. This is how data gets from our client to end users. And typically these end users are downstream from our client. So like we sell to our client, and then our client sells their apps downstream to other clients. This is the basic rule and where you want to get to with everything. You don't want to have to touch anything. So what we've done to allow secure uploads to us is the first principle is clients do not have an AWS account. We don't give them any credentials or any keys. They actually have a username on our platform. This actually just uses Django authentication right now on the back end. So hey, they have this account with a password. We'll send them invites and they can access it. So we have a command line app that they can install. It's pip installable. And this allows them to log in to the API, and this will give them a scoped S3 policy that allows temporary upload access to a specific randomized prefix in S3. We further scoped this down to client-specific prefixes. So when a user logs in with the command line, it actually uses netrc for authentication. This is the same thing used by the Heroku command line and a lot of other applications. But that gives them an API token. And so once they get this, the data is actually uploaded directly from the client's machine to S3. So we never touch it. And the main reason for that is because if we actually allow the upload to our service in some way, via the API or via a web interface, we would actually have to carry a lot more risk by acting as a file proxy. This has a lot of other logging and access rules around it that we want to avoid. So the file goes directly from the client to S3. So from that point, it's in a randomized location. First of all, I should mention on the ETL front of this, we are not 100% there yet. We still don't have all the automation pieces done. We have a very good idea of where we need to go, and we're about a week and a half out from finishing this up. But we have some things that move the files from this randomized location into a place that our ETL jobs can pick them up. And we run these ETL jobs. For PHI-based apps, we have to run these ETL jobs on EC2 instances, not on ECS because it's not approved. So we've developed internally a Luigi-based ETL library. For those of you, anyone here familiar with Luigi? It's a library from Spotify. It's basically helps to determine task order and execution. So you give it a list of tasks that need to run. It checks to see if they need to run and determines order and makes sure things aren't running at the same time when they shouldn't. So we've built something around this a little bit, abstracted it some. Yeah, from that point on, we want to get to an event-driven type model. So a user uploads the data, we fire off an event to our service, and then we have other services that pick up, move the files, and load the data in. These are pretty basic loads. When it comes to Redshift, loading data into Redshift, you either have a CSV file or a JSON file in S3, and you issue a copy from command, and so it just copies it straight into the Redshift tables. So at that point, it's actually in Redshift, and Redshift's an approved service because it has encryption and it has all the logging. So the logging actually Redshift has is there's a user log and a connection log, and those are the main things you need for HIPAA compliance, and you have to enable this when you create a new cluster. The user log logs any creation or modification of a user or group, anything that might affect access rules to any PHI data. And it also has a connection log, which logs every connect for a query and where it's connecting from, that kind of thing. So once we got it in Redshift, we're pretty happy. And now our application, which is Django based, and we're running it on EC2. So the main thing you have to have for EC2 is what's called dedicated tenancy. This is why people don't run PHI compliant apps from home or for personal use, because the dedicated tenancy is a $2 an hour charge on top of any server costs. So you're looking at $1,400, $1,500 a month. And dedicated tenancy means that it's actually running on dedicated physical hardware from Amazon. So no other applications should ever interfere. And they require that for anything that processes PHI. So our application itself, I mentioned we use Django authentication for the back end. We had to implement password policies, and that means complexity and also rotation policies. And the third thing is we have to actually log still, just like any access to PHI, we have to log the access to that. So when they load the app, any access to an app that contains any PHI data is required to be logged. So we log the user, the IP, and what they're looking at when they looked at it, and that kind of thing. And we also do a browser session expiration. So if a user walks away from their computer, we can expire the session on the front end, so people don't scroll through the data in the browser. All right, so a little bit about the difficulties that we've had doing this and where we've struggled. So I've learned so much about IAM in this past 3 months, and even more before that. But IAM is deeply powerful and complex, and I've come to love it. I don't know if I hate it much, maybe a little bit, but I love it. We've also had to learn, since we're using multiple accounts, we've had to learn how cross-account policies work, and we've had to learn how all the roles work. And this varies. You have login from devs, sysadmins, and that kind of thing. But different services like Redshift can assume roles. You could have Lambda assume roles. You can have ECS tasks and services assume roles. EC2 instances themselves have roles. So we've had to learn how all that works across accounts. And we've had to learn about KMS policies, which are fun. You have to create a policy that still allows root accounts and administrators to manage the key, and then you have to create policies that allows Redshift to access it and S3 to access it, and every service that might use it requires some type of permission change in the KMS policy. Now, we've also had issues with AWS changing things out from under us a bit. One instance of that is we started using ECS pretty early, and it wasn't that long ago they added task roles, which is so any ECS task you launch can assume a role as well. The way that worked was one way, and our app was working, and they changed it, and it wasn't working. So that was fun. We've also spent a lot of time learning Terraform and learning, all its bugs and various things, and we've learned how to abstract all our infrastructure into that. And at this point, we've got a point to where we're using reusable modules. So like we create a module for EC2, or we create a module for whatever thing we need to create in AWS. And then we have modules for specific clients. So the idea is we have a new client, a new enterprise client, and they want to spin up all these services for themselves. And we dedicate these per client that wants to do HIPAA stuff. Their stuff's all isolated in a lot of different ways. And so it's nice to be able to copy and paste a module, new client, boom, and you've got all the things you need in AWS. And I remember before I started using Terraform, things that I'd set up in AWS had been manual. I didn't realize how many things the console automatically sets up for you in the background. All these policies and things that I had to learn were things that AWS was just doing for me. But when you're defining it in code, you have to have a much better understanding of how that all works. So that's basically my talk. I'm going to leave the rest open for questions. And just a heads up, I'm hearing impaired, so I might need help hearing. I'm going to pass around this mic if there are any questions. So right now, there's a couple different things. CloudTrail logs, it supports actually sending to SNS. So anytime CloudTrail delivers logs, it'll send to an SNS topic, and we can react to that. Right now, actually, in this new HIPAA environment, we're actually, we pushed our deadline back to the end of next week. So we're actually not ingesting those logs. We've put the framework in place to put them there. We have a standard elk stack. So we'd be processing these with Logstash and putting them into Elasticsearch, and then we'll do our audits with Kibana dashboards and things like that. But as of right now, we're not ingesting those. Anyone else? Well, all right then. You'll notice I put some. Oh, okay. Go ahead.
How do you handle source control for your Terraform files?
Well, we use Git. That was probably a good guess. So the basic structure is we have an infrastructure repository and we have an infrastructure modules repository. The infrastructure modules repository is where we build out all our reusable modules, and we can tag and version this repository. And then in the infrastructure repository, when we use these modules, this is where we actually pass in client-specific variables and things that might differ between environments. And we can actually tie those to specific tags. So for example, we tag infrastructure modules as 0.1. That's what's in production. And then when we want to update it in dev, we'll remove that tag and promote it through by changing that version tag.
I'll hand it right back. On your way to arriving at using Terraform, did you look at CloudFormation templates? And what made you choose one over the other?
I personally don't have a whole lot of experience with CloudFormation. I do know this syntax hurts me. So a lot of that was, a lot of the things in Terraform was just, we like the cleaner syntax better. We found that they tend to add support for AWS services very quickly. So a new AWS service comes out and there's a Terraform resource for it, in a week, if not less, It really just come down to we liked it. And it had its quirks, but it worked best for us. All right, well, I got nothing else. Okay. Thank you, guys.